Hi, everybody. This is Kubernetes SIG architecture meeting for April 16th, 2026. And looking at the agenda, and looks like Omar, uh,
Yeah,
you are,
hi.
do you need to share your screen?
No, you can just get into the link that I shared here
Okay.
if you want to. And basically, it's really simple. And HBA has two different APIs that are active currently, and we want to fix this situation with a couple of options. And we talked to Matcha, and we think that the most appropriate option is to just deprecate V1 API. We have two that are currently active, which is V1 and V2. And we want to deprecate v1 and just continue with v2. And please share your thoughts.
Sure. Well, we don't do that too often on a GA API. What have you looked at the published policy and what the requirements we have? I think we do allow it, but it's not something we've done often. I'd be curious to hear Jordan's opinion. I see he's on here. Uh,
I'm digging up the. Basically, we don't remove GA APIs. We said they were stable. You integrated with it. We won't. We said we won't remove GA APIs until the next major version of Kubernetes, which basically means we won't remove them.
Never.
I can.
Do we have to keep round tripping V2 stuff
Um,
forever?
well, the way that the API works is all versions can be read via any version. So if you created a v2 object and persisted v2 stuff in it, that instance is readable via v1.
V1. Yeah.
And so the question is, what happens if someone like reads via v1 and then writes, adding an annotation or something? Like what happens to the v2 data? So the answer is yes. It had like whenever you write via v2, those objects are readable via v1. They can be written to via v1. We can decide what happens in that case, I guess. Like losing the v2 data, dropping the v2 data. We haven't said that's okay before. If I mean, there's a lot of things that are novel and unusual about the HPA API. So the way v2 stuff round trips into annotations in v1, I can't think of any other API that we have that does that. Um, so if we want to talk about ways to make that better or more consistent or changing the current unusual behavior of HPA, that could be fine. But we're not going to drop the v1 API. We're not going to stop like round tripping one object to another.
So um, I've I'm very new to this community, and I've heard that phrase before of um, V2 to V1 and storing the data as annotations is unusual, and other APIs don't do this. What are the alternatives that we could look at to store V2 data in V1?
Um, what we've done in the past, or what we do for other APIs, we add fields into older versions. So if you add a v2 field, then we would add the corresponding field to v1 so that the API server, which is up to date with the latest releases of Go types, could round trip the v2 data into the corresponding new field in the v1 version and could return it to clients. What those clients do with it is kind of their business, right? If they are an old client linked against old v1 Go types that don't have that field on round trip, they might drop those new fields and then try to write back. But that's kind of their responsibility. Like a client can always drop data and mess up data.
So is that a little bit more like what option one is, which is, I don't know if unifying schema is exactly what you're talking about, but basically take a bunch of V2 and put it into V1 so that they're looking more the same?
Yeah, I don't think it's closer to option one. So
Okay.
option one is
You
saying,
can't break the V1 clients, right?
Yeah.
Yeah.
So V2 took, it's been a while since I've been in HPA. I think it took singleton fields from V1 and made them list fields. So in V1, you only had one type of thing
CPU
to
only.
scale on. And in V2, that became one of many. So you could have a list of things, and each entry in the list could be one of a few different types. You could have CPU or object or custom or container or whatever. And so like figuring out how to round trip from a list of union types to a single CPU only type, that's tricky.
I mean, you could do something like, right, like you populate the current field with the first one, and you add another field that contains the rest, or contains all of them, or whatever,
I
right?
was wondering about that. So it's almost like we take V2 and we remove the CPU only piece of it, and round trip that into the opinionated CPU thing of V1, and then shove the rest into V1 of V2. So
Something like
you
that.
can still define resource metrics and object metrics and all those things, but okay, it could get weird though, because take a V2, somebody could define V2 CPU resource looking like V2 but in the V1 API, and they could define a CPU in the V1 scheme at the same time. And then what do you do with that?
Yeah, the closest parallel I can think of is what happened with custom resource definitions between, I forget if it was between the alpha and the beta or the beta and the GA. But I think in the beta for custom resource definitions, you could only define a single version. So you said, this is my version and here is my schema. And then in the GA, you could define multiple versions, each with their own schema. And so it was a similar kind of one top level thing versus a list of distinct things. And the way we round tripped that is we said, in the beta version, you have to include both, and the top level one has to match the first item.
Okay.
And so, like if you go to an old client who isn't aware of the new fields, they're just going to throw away the list field. And so, like, that's fine. They come back with just the singular data, and like at least it's coherent. A client that is wanting to interact with the list is going to be using V2 anyway. Like no new client that's wanting to maintain and mess with stuff is going to be going back to this awkward way of like double representing the data in V1. If we wanted to bring things from being annotations based to being field based and trying to get out of the weird things HPA is doing, that could be one possibility. We basically take the list from V2 and we put it in V1, and then we also represent the CPU based thing as the top level thing to preserve reads by V1 clients. That's one possibility.
This is potentially a bad idea, but forgive my ignorance. But is there a possibility of storing the data, the V2 data in the V1 API as something more structured that is not under spec? So metadata dot the V2 API, just shove it in there in the struct.
Metadata, the type for metadata is shared among all types. We don't have a
right.
API.
No, he means
No.
he means you'd have metadata, you'd have spec, you'd have status, and you'd have
No,
extra
that was
spec.
my second question. I was wondering either metadata dot, the V2 API there or top level. And I'm assuming
So it
top
would be
level won't
top.
work because it's got to be spec or
Any
metadata. Those are
any
only two
new
options.
field, like any field that existing old V1 clients don't already have in their Go types
Yeah.
is no better and no different than just adding stuff into spec. The benefit of putting round tripped V2 specific stuff into annotations is that all clients already had a map of string where they would just sort of carry along this opaque data that they didn't understand, but they also wouldn't drop it. So any new field is
Yeah.
you're already going to be lossy when you round trip through old clients with old Go types.
Okay. And I'm not thinking about the client, I'm thinking about the server side. But yeah, that does make sense.
I think
So
what you're thinking about is like, is there a way you don't have to custom craft V1 changes every time you make a V2 change by just dropping the whole V2 spec
Yeah.
into a parallel spec called the V2 called spec V2, that but in the V1 API that's just used for round tripping.
Yeah.
I think
And I don't have to worry about that the conversion of the types or anything weird like that. We just shove it in there and let it do its thing.
But
And
then what do you get from what's the benefit of that, of the annotation round tripping? What do you get from basically storing it in the spec or whatever, then storing in the annotation? What's the value you get from this?
updates via the V1 API don't throw away data if the client was old and didn't preserve those new fields.
you
That's
get that with the annotations, not with the
but
fields.
right.
yeah.
That's the
Yeah.
benefit of the limitations.
Um,
But they could make an inconsistent change, couldn't they?
so could we switch gears to the deprecate option? So we can't remove APIs. Uh, I guess we could deprecate, which basically says we no longer update this, but we have to continue supporting this. Could we could we change our promise around what data we're happy to persist in the annotations? Like we're adding a new field to V2, and if you round trip it via V1, you might drop it. Or do we have to keep that promise as well? That's probably also gross.
Um,
I think your question is, can we make V1 writes lossy? Because the clients are going to be lossy
From a
anyway.
moment in time. So we like up until today, they're not lossy. Could we just say any new feature will be lossy, and we're not going to bother round tripping it via V1? But that sounds awful as well.
that's unprecedented as far as I can remember.
I mean, I
Uh,
think the question is, do we really believe there are V1 clients doing writes that need to be compatible with V2 out in the wild? I mean, I'm sure there are, but do we care?
I mean, the most likely instances I can think of are ones that are doing just metadata updates, right? They're just like applying labels or applying annotations or like they're not even trying to mess with spec stuff.
Right.
They
But
just
you don't
wrote
want it
some
to be lossy.
integration
Yeah.
8 years ago. It's like, oh yeah, label all my objects of all types, and they integrated with the V1 API because that's what existed at the time. And so yeah, you should be able to read a V1 object, touch some other part of it, and write it back without trashing unrelated data.
Yeah.
It might be too late for this one, but I was looking around. Do we have any guidance written about when it makes more sense to do like an ingress to gateway clean type break versus like trying to do a V2 that is really different? I feel like that
Probably
might be
not.
something to put in the like API guidelines.
I mean, ingress, like the cardinality of objects was different. Ingress to gateway, like for every one ingress object, you have like multiple different orthogonal gateway objects. So I'm not like
It's
that
not the
one was
same
kind of
thing,
unavoidable.
but it's it's only an example I can think of off the top of my head where we had a core type and we have just a very different sort of superseding type with a different name, so you don't have to round trip them directly, and that's sort of a separate problem. And we just froze the like V1 type.
Does that mean if like do we call the loss an HPA then? If that's the route, we go, whoops, the round tripping didn't work here. We can't really go back on our promises because everything's GA. So we just kind of have to end it there and just tell everybody to move to a new API.
I don't know if you have to, but I couldn't find guidance for when you should, and I feel like
Gotcha.
maybe we should follow up with that.
All right. I'll add a couple comments into the doc, but maybe we can move on to the next topic. I think we ruled out a couple options and maybe gave some clarity about what direction would be an option.
Thanks for the
Okay.
info.
Sounds
Thank
good.
you.
Then I think Patrick is up next
Yeah.
for the
Okay.
rest of the meeting.
Sorry?
You're up for the rest of the meeting. It's all you.
Well, the first one might be fast. I was just trying to get awareness that this is going on. Antonio suggested at some point that we should have tighter tracking of our critical Go packages like client Go and API machinery. And what he came up with is one thing where he dumps the public API, and he wanted it to be so that incompatible changes need to be documented and need to be called out. But his initial PR didn't have that part. And we talked about it at KubeCon, and I volunteered to do the critical breaking change tracking. And this is basically what I came up with so far. I know that I'm probably going to change a few things, but I want to get people to think about the workflow and what it would mean for developers. The underlying idea is that if API diff identifies incompatible changes in client Go, the tooling that we have in our API diff script will then look for the exact documentation of this incompatible changes in a new changelog MD file. And if there is exactly that change with some additional documentation, then the API diff script will not fail and the job will pass. But if it's missing, it's a job failure, and we can make it a merge blocking failure if there are such incompatible changes. So that's a rough idea. And I just wanted to get people to perhaps look at it, think about it. I raised a few points where I think it could be improved. I wanted to
So
give
your goal here to at review time for people to potentially block or feed or just ask for changes that maintain compatibility when it's feasible, and if not, then at least just make it more discoverable.
It's both. It's basically making sure that incompatible changes are really noticed by the reviewers and by the developers. Right now, they might be missed because our API diff pull job is optional. So people might not run it or might not see it as something that they need to fix. And this requirement to have breaking changes documented in a changelog, that would mean that they have to deal with it because it would be merge blocking if it wasn't. And then the other is that if we make a breaking change, we write about it in a changelog file that then consumers can consult to see what happened, that the code is no longer compiling, and what the recommended approach is to deal with it. So it's both. It's for users, for developers, and for us as reviewers to be more careful.
Hoisting a filtered view of the API, what the API diff detects, that requires changes that we want to be noticed and be considered to show up in the pull request. That seems useful. I need to read through to see if we're filtering at all.
We're not.
Thing is,
yeah.
Anytime
API diff,
API type or add an API version.
Yeah, I have exactly that encountered. I did the work afterwards. I went through all the changes going into 136, and you can see the generated changelog in my PR, what it looks like for some of the things that we did change. And one of them is exactly that. V1 beta 2 of device stains modifies the generated interfaces for client goals. That is an incompatible change. It will be a bit annoying to always write about it when we know that it's harmless. But yeah,
if we can filter out what we would consider to be noise,
that's harder, I suspect.
Maybe. You've had your hand up, Antonio. Go.
I just wanted to give a bit more of context because this is a work that we started, like, I think that was 2 years ago, right? To see if we can have a better client, if we can reduce the dependencies, and the conclusion after a lot of people working then and a lot of people here is that we need to live with these APIs here. And the problem is that the more now, they were pretty stable during these years, and now we are adding things, and these things are breaking. And we don't have a good way of seeing what is breaking. And we are depending also a lot on the context of people. What Patrick and I discussed is we need to find a way that is more mechanical and more enforced by the machinery in the repo, and that also allows people to go and track the changes. So I think that what I wanted to ask Patrick is, what we discussed is we are going to implement both things. Your thing that you're presenting here, and the other that was suggested by Jordan to me some time ago of following what the Golang team is doing, of dumping all the public objects into a file, so you are able to. Is that correct?
I think yes. I think we need both, because if you dump the public API into the file and then in the review, you see the change. You see perhaps some exported symbol that shouldn't be exported, and someone just didn't think about it. I think that your approach with dumping the API and then having it show up as a diff in that dump in a PR is useful.
And then from Jordan, another review is this excessive is something that we need to face on and iterate.
I don't know. It's always the balance of, you make something, you increase visibility, and then you overwhelm people with like the detail and the generated files, and it gets so big and so verbose that no one really pays attention to it anymore. If it changes so often and is so verbose, people won't look at it. So I'm trying to figure out if there's a sweet spot where we can capture the parts we decide we care about. So that when it changes, it's actually meaningful, and it's a good reminder to check that we're increasing the surface area in a way we care about, or we're not breaking the surface area in a way we care about. I suspect it looks I suspect we'll want to try to filter out some of the generated pieces that change with every introduction of a version or a type, if we can.
Yeah, no, that I think that we need to define. The problem is that the repo is a dumpster, right? It's everything goes there. There are things like cert, whatever tooling that shouldn't be there. So I think that the question is, what will be something that's considered as a good signal and something that is considered as noise?
I don't know that it's totally noise that we're dropping the APIs. I mean, that is like a visible change for users. I just don't think we should have to hand write anything about it.
Well, handwrite, it could be as short as saying changing versions. And if it's obvious, you don't need to write anything else. But it needs to be in that change. In this breaking change case, it needs to be in the changelog MD. In my workflow, I have an API diff -u flag implemented where you basically run it in your branch and it will update the file for you, where you then just need to do very little manual editing to keep the changelog MDN file up to date. It shouldn't be too onerous. I was aware that this could be a stumbling block.
Yeah.
But I think I think at this point it would be useful to people to look at that and see whether it's looks bad or is too onerous.
If we incorporate that into something like make update as well, so that when people make changes, it'll populate that, and then the reviewer can decide, like, is this reasonable? Is this not reasonable? Yeah.
I like that. I also like that it means that we can assign, say, the like top level client Go approvers to specifically approve that file, even if the change is somewhere in a leaf package. Like you had to touch the change log, even though it's auto generated. Someone that owns client Go overall should take a look at that.
Yeah.
We can set up the owner's file to flag that particular changelog file.
I don't think that we have a problem of approvals. I think that we have more a problem of visibility on or understanding the change. I think that during the last 3-4 versions, everything was smooth. The problem is that when there are these big changes, it's really hard to understand the consequences.
That is a good. That's a good point. I think you had a documentation PR talking about what types of changes we want to allow, like additive changes versus changing signatures of existing methods, things like that. Like
I have a draft written for that. I haven't submitted it in any PR because I wanted to basically let it simmer for a while, see what else I can think of that might go into that. Then this tool here was one thing that I wanted to add to that documentation. So I kind of first had to write the tool so that I know how to describe it, at least roughly.
So I'm supportive of the direction. I would like to like play with it to see if there are things we expect to happen a lot that we think are noise, if there's a reasonable way to filter them out. And I think David was on there. He's out this week, but David and Ben and Antonio and I are probably the ones who talked about this the most with you. And so let's say anyone who wants to have an opinion on this, take a look at it between now and the next call and comment on the changelog example. Thanks for capturing that. To say, like, this looks good, or can we exclude this, or would it be better if we did this alternative? But yeah, thanks for doing this to raise visibility to what's changing, instead of it just being a red optional job that we sometimes look at and sometimes don't.
Yeah. Okay, sounds good. I look forward to the feedback. Now the next one is about API changes that we made for DRA in 1.36. So it's kind of already decided, but I wanted to call out perhaps something that we could have done differently and better. So it's coming back to the age-old question of what happens if we have new fields in a file, in an API, and they get dropped because the fields are feature gated. And in the review, we have that situation where the cluster is basically upgrading from alpha to beta. The API server enables it, and the user thinks that they can do something, but the rest of the control plane hasn't been updated yet. So that's the other scenario that I want to go through. So I think, first of all, behavior in the API server, the first bullet point, I think our current implementation of dropping a field is really just bad. And I was hoping that we can make it a goal for the declarative validation effort to improve this. Well, The problem right now is that if an API server doesn't know about the field, the client can ask for strict parsing and they will get an error when the field is unknown. And then suddenly we have an API server that knows about the field, and now you can't get that error anymore because it's not an encoding error or a decoding error on the server. So I think that's to me not even, well, it's obvious what we should be doing. The question is whether we can and who's doing it. Yeah, there are some cases where we can have the API defined in a way that if a field gets dropped, it's a validation error, but it's not always possible. This whole discussion about unions and one-offs that goes in that direction, but it's basically not always possible in advance. Sometimes you have to add something and old clients will not notice. Okay. Yeah, it's exactly this field validation where I would like to see same behavior if a field is disabled and give the user a warning, give them an error if they have asked for it.
Yeah, the logic around dropping fields was that we want to behave like an old server before the field was added. And so by that logic, what would an old server do? Well, if you kube control apply, by default, kube control apply says field validation strict. And an old server that doesn't know about this field, if you try to send it, will error because you told it to. We are pretty consistent about where we do this dropping. It's almost always done in the strategy, prepare for create, prepare for update. And so having all of the places that drop fields return, like accumulate the field paths that they dropped, and like then taking the directive from the user and warning or erroring, that seems totally reasonable. I would be happy to see that happen.
I tried to do it manually, and it turned out to be quite a lot of work. So that's why I'm looking towards the declarative validation, where the API is defined so that that code could be generated to do their checking, and they must. Do they do the dropping? No, they probably don't yet. That's all manual, but it could be automated.
Not last week, 2 weeks ago in SIG Arch, we actually talked about declarative behavior and field wiping.
Yeah, we have like almost the whole hour. Did I put that recording up? Were you there, Patrick?
No, I wasn't.
The recording's not linked.
Sorry. I can put the recording up. You can.
Yeah. So making that happen in a generated way seems like a good idea. I don't think it's quite the same as validation.
It's not. No, it's a different
it's a layer before validation.
Yeah.
But doing it in a generated way, so that we can do it consistently, so that it happens automatically, so that we can tie it into honoring the field validation directive. That could make sense. I'm not sure if the declarative validation folks had that in their backlog of like other request handling things to do in a generated way, or if they just said, oh, it's not part of declarative validation. Okay, I guess we won't do that. I'm not actually sure where we left it with Aaron and
well, I'll post it and we can go back and look. Or I don't know if it's captured in the notes or not.
Yeah. Okay. Yeah. But for the sake of time, let's move on to the other scenario. The one that is kind of inevitable. If you start with an alpha where a feature is off, at some point you will want to go to beta where it's on by default. And then during that upgrade, we end up with a situation where the API server for a short while accepts the new field, stores it, even though the rest of the cluster hasn't been updated yet, because you have to update the API server first. So there's always a time period when there's version skew, and the version skew implies that feature might be on in the API server and off elsewhere. So given that this will happen to all APIs, how can we deal with this so that it has the least just potential for disruption? In general, I think if you are in a controller or a client with a feature disabled, the traditional recommendation that I've always hear is you emulate the previous behavior where you basically don't know about the field. So basically you pretend that a field that is set and you know that it is set, but you still ignore it. That's one thing that how feature gate checking in the control plane controller sometimes happens.
I think, Patrick, you've implemented where you detect it and you say, "Hey, I don't know what to do."
Yes, that's my third point. So I go through the things that traditionally have been done and where I've been unhappy. So the ignore field, I think that's basically you emulate the behavior of the pre-alpha, where basically your code didn't know about the feature, and but that's kind of sometimes bad if the field actually really needs to be considered.
Yeah, like with sidecar containers, we had this same thing, right, where it caused all kinds of drama.
Yeah. So the second option is you see that the field has been set, but your feature gate is off. Sometimes, I think Jordan made that comment, then the client should honor the field and do what's required for the field or what the user is asking for. The problem is that the feature gate might have been necessary at startup time to actually do the work. And we've seen that with the resource claim generation for pod groups. The controller can see that a pod belongs to a pod group, but it can't do the corresponding resource claim creation when the feature gate is off because it needs information about the pod groups. So the second behavior basically cannot always be done. Sometimes the code sees that something is being asked for that it can't do. And that leads me to what I really would prefer to have happen in that case. That's the third option. The client basically sees, the controller sees something that it should be doing. It knows that this feature is off, and I would like it to see, to basically fail in a certain way that can be retried later on when restarting, say, the controller manager. And then it should pick up and continue and do the actual work now that it also has been enabled across the entire cluster. And we had a few cases. The resource claim example basically means that if the controller ignores the field, it will create one resource claim per pod instead of one resource claim per pod group. And then basically the whole workload can't really run properly. So it's pretty bad to just ignore the field. I think it would be much better in this case for the resource claim controller to say, I see that you want me to do something that I'm not allowed to do. I'll fail. If to fix it, you need to upgrade the rest of your cluster. I think that's my preferred approach, and I see that applicable in a few cases.
So this is specifically talking about things above the API level where we're not dealing with skew between versions of the controller. No. A controller or kubelet or some actor sitting on top of the API, and it sees an API field connected to a feature that it doesn't have enabled.
It's enabled in the API server, not in the client. So the client's updated, it can read it, it can see it, but it's like, whoa, what do I do? Because my feature's not enabled.
Yeah, and these are basically the three options that I see. And the first one, the traditional one in quotation marks, is not necessarily the best approach, in my opinion.
It's not safe in some cases.
Yes. It depends on the feature. If it's really an optional field where it's harmless to ignore the field, then you can do that. But if it is something that changes the actual behavior, then it might be better to throw an error and not do something that is harmful or hard to clean up later. Like scheduling all pods with the wrong resource claim basically means that an admin will have to do a lot of manual cleanup work if that happens during a cluster upgrade where the API server enables it first. And I think we can avoid that with a bit more planning in the alpha stage, because that's when it matters, when we know that at the point of graduating to beta, the control plane will have the alpha implementation. And if that alpha implementation is safe in the face of version skew and feature gate skew, then we are okay. We know that we just need to complete the cluster upgrade.
So in the case of you haven't upgraded, say, the scheduler yet, you're gonna not see the field at all because it's gonna get dropped, right? You're not gonna deserialize it,
Yeah.
and so you're gonna do the bad thing. And I guess the current plan is, hey, work like the old scheduler when the feature gate's not off, do the bad thing. And you're saying we can do better than that in this subset of cases. We can't do better with the old one because unless it can detect like you've done where it's like, oh, I see this thing and there's an enum value and I don't know what the hell it is. I'm not gonna do anything. But beyond that, it's hard for it to do anything.
Yeah. It's basically when we consider valid version skews where we say that in your cluster, there must be at most one version difference between, I don't know, control plane and API server. That would mean that if we introduce an alpha version in one release, by the time that people update to the next one incrementally, we know that the control plane has support for the field because it was in the alpha version. But if we don't plan for it in alpha, we might have to do a second alpha or accept that the beta graduation can be bumpy.
Yeah, I'm not sure about failing. Like deciding, seeing a field connected to a feature that the controller doesn't have turned on and saying, I can't handle this object because I don't have that feature, and adding a condition to make that visible. That I can see that. Wouldn't you want, when that controller got upgraded with that feature on, wouldn't you want it to just start syncing that object as
yes.
if? Okay, so
that's exactly the goal. That's exactly why we
clarifying. Like we don't mean necessarily fail, like mark as terminal or error or like whatever that object terminal failure state is, but maybe ignore the object, like no op the object. Say I can't handle this, and if there's a conditions that we can record that backed in or an event or something to record that, to make that visible, that seems, I can see that.
Yeah, that's exactly the plan. Basically, don't do something harmful and hands off until you are updated, and actually events or conditions to inform the user what's going on. That's exactly what we should be doing.
Okay, if we tweak fail to ignore or like no op, I think I agree with that third option. And this is specifically for like an existing API that has an existing controller and we're adding a new field or a new feature to.
Yeah.
For brand new APIs where the whole thing is under a feature gate, if that gate's off, that controller loop isn't even going to get started. And so that we're already in the state where the controller wasn't even running because you had the feature off. So you create an object of that type, it's just going to sit there not being handled by anything.
So yeah, but you just requeue. Yeah. You mean requeue, not fail, like right?
Right. Yes. Yeah. Yes. Yeah.
Yep. The retry, like the retry is finish upgrading your controller, and when you start the new instance of your controller with this feature turned on, it will see these objects and start handling them normally. Thinking about the life cycle of that condition, like would you expect controllers now to clean up that condition Yeah, that gets messy.
I think
I don't think you need
I
to
think
record a condition. I think you just need to send an
an event would
be in
already
queue for later.
be good enough for kubectl describe. Yeah.
I mean, I guess your queue could fill up with a whole bunch of crap that you just keep cycling through and ignoring every so often, but
Yeah.
okay, is that it?
That's pretty much it. We have a few specific cases, but we can go back to those with a new common understanding and perhaps change a few things. Because I think
thinking about types of controllers, like here, we expect the control plane and the controllers to converge to identical feature gate enablement states, hopefully quickly. Like we don't expect them to run with different feature configurations in a long-term persistent way. And so hopefully,
except we run long versions queues when the feature is flipping to on by default. I mean, people could keep their nodes running.
Well, I'm talking about controllers.
Oh, you're talking about control plane, not
control plane.
Okay.
So sometimes it takes
yes.
hours or in the
Agreed.
worst case days to finish a big control plane upgrade where something hit a problem and you were running skewed, but it's still like hours or days.
On the control plane
nodes, we do expect to be skewed multiple versions with different feature gate states for months, up to a year maybe, which is why the node feature detection KEP was so important for an old node to be able to signal, I can't handle this pod, don't send it to me. So I think that's a useful distinction to make. What we're talking about here are controllers and control plane components where we expect a mismatched feature state to be short term and transient. And so don't touch the object. Hopefully the upgrade will complete soon, and then you can touch the object is reasonable. And where we expect it to be long term, like the node, we actually need signaling to like keep things that the node can't handle off of the node in the first place.
Yeah.
Sorry, can I ask a newbie naive question? The skew policy says that you can run one major version behind. One minor version behind. So Kube Control Manager could be one minor version behind Kube API Server. And the scenario you were saying is the expectation is that Kube Controller Manager would be upgraded within hours or days. Is that documented or expected? Like I'm thinking Hiram's law. Somebody upgrades the API server and then 6 months later upgrades Kube Controller Manager.
Yeah. I don't know. Like the reason for the one version behind skew is so that you can run version matched controllers with an API server and it will not break if you upgrade a different API server first. I actually don't know of anyone who intentionally runs control plane controllers older than their servers separately. Everyone I know of pairs them, but I'm sure someone probably has.
It's not hard to add a sentence that says, this is the
like the expectation that it's short term and converges, and that this allowed skew is just so that you can do your upgrade in either order. That we can add that to that doc. I'm trying to find.
Because I'm just wondering.
No, we do. We say they're expected to match the Kube API server minor version, but they may be up to one minor version older to allow live upgrades. So yeah.
To allow live not to take your time and do an upgrade over 6 months, but to perform an upgrade in a reasonable time.
This queue is so that you can do a live upgrade and have the controller running one version back while the upgrade's running.
Right. It's not a normal operation scenario. Cool.
Someone's definitely going to do it anyhow.
Someone's doing it currently.
I mean, if they're not coming and complaining to us. So more luck to them.
Before you kill the call, we had Patrick on so much, but your your sweater there's been cropped. What are clouds made of?
Linux servers, of course.
Thanks.
That's awesome.
All right, everybody. Unless there's any other quick items, let's wrap it up for today. Okay.
Thank you.
Thank you. Bye bye.